So I'm Marcelo. I work for a company called Envica. It's written on my shirt. This is a group that includes Sensio Labs UK and Session Digital and Envica itself.
And I'm Konstantin, mostly known as Everzet on Twitter and GitHub. And I am also proud part of Envica company.
Right.
And we're working with this crazy guy doing crazy things together.
Yeah, I get to walk in and see people like that every day. So this talk is going to be about, we have it structured in three ways. We're going to talk about convenience. There's an aspect of framework that's maybe how frameworks are sold in the first place. You have a lot of convenience features, and we're going to talk about that and contrast with other things. And we're going to talk about choices.
Yeah, and there is thing that people are getting into lately about the choices and design and how you make those choices in your project. And we kind of get past it without even thinking about it. We're kind of starting to think about good and bad instead of thinking about what matters. And this part of talk will be the most important part of talk, where we'll kind of try to cover it.
When I told Everzet that I wanted to talk about this, he said, yeah, I want to talk about that too. I said, well, why don't you talk about that together? And then when I start hearing his ideas, he's like 5 years ahead of me. And I said, wow, okay, so you do that. You write that code for that demo thing, and he did, and that's the last bit of the presentation.
Which is the future.
Some ideas that he had that he's going to put into Behat as well to adjust to try and keep up with our ideas, make the tools help us with what we're trying to do. So let's start with convenience, the carrot at the end of the stick. Right, so you should use our framework because you get this feature, you get that feature, you get that feature. And we fall into that promise. We like it very much. By the way, let's just do here a disclaimer. We love Symfony.
It's not about removing Symfony from your code. It's about leveraging it in the best possible way and using it as best as possible.
Yeah, so don't take us the wrong way.
Yeah.
If you go, what is Symfony? If you go to the documentation, try to find out what is Symfony, you find that this code is there. Framework is just one of the tools to help you develop better,
and it's
help you develop faster.
It is actually the quote from documentation, and I find it really fascinating because once it's just, and there is also, it's one of the tools. So there is a lot of skepsis there in the official documentation about the tool. It already kind of puts you into the mindset where you don't need to think about this as the only thing in your project. It's just one of these things, just one of them.
It's really cool. And if you ask a developer what you want to do, what is important for you, what kind of is important, what do you expect from a framework, what kind of code you want to write? I want to write clean code, man. I want to write stuff that is really, really cool. You know, this comes second. But what about, writing code, fast, efficiently for your customer, and writing code that, using a framework that keeps your code cleaner by the way it's structured. So this is a very nice way of putting focus on the right thing, right? So when you look at the mentality of people when it's writing code fast, it's like even some project managers think there's this switch that they can turn down. Okay, we have to deliver that on day 20. And how do you do that? I don't know what you do. Stop doing tests, stop all the quality thing, and then we can go faster. This imaginary switch that you can turn down quality, and by some magic reason, you're going to go faster. That's the mentality of people.
Also known as Hacker News switch.
The Hacker News switch. So, yeah, so if you try that theory, you may find that it doesn't work. That there's something wrong with the transistor there. Uncle Bob puts it really well. He says the only way to really go fast is to go well. Like the code. If you really want to go fast, do it the right way from the beginning.
Yeah, Uncle Bob talks about this a lot, but he uses this particular way of delivering message which most people don't get. So we will try to clarify this a bit today.
So yeah, so it seems to be two ways to look at frameworks, at tools, and what is the components of these tools that make the code more convenient or maintainable. It's like two forces there. And if you look at that, this is all over the web, relative cost of repair. As you grow in your project, and I think it was a quote to this on Jakub's, if you were upstairs, he says, as you go further down on your project, it gets harder and harder to evolve your code. The complexity just grows, and to fix anything, to change anything, becomes just more expensive over time. And then he says, that's not necessarily true, because you can fall into a sustainable pace if you keep the inner quality of the code, right? That was interesting. So there's some qualities of the code and some qualities that you can put around the way you write you use a framework. Then can kind of reduce the exponentiality of this curve, make it easier for you to evolve your code later on.
Yeah.
Right? So there's a battle between convenient and maintainable. So let's have a look at that battle.
Yeah, so there is another name for convenience nowadays, and it's like we hear this a lot. Especially I heard this a lot when we switched from Symfony 1 to Symfony 2. Another name for convenience is conventions. And there is this battle where people believe that putting a lot more on conventions will give them ability to drive code faster. And there is another camp of people that believe if they do not follow conventions, they will put a lot more into architecture and design. They will go slower, but then they will get a benefit. And there is this trade-off between those two that you need to make on every project. And this trade-off is not necessarily about being small or being big or changing project. It is about how big you want to get rather than how big you are right now. It is about, do you want to evolve your project into something else later on the road? Or do you want it to be that small? And there is always a trade-off, and this trade-off could change every day on the project. And this is kind of this thing that we're missing constantly.
So the magic is to get something that is convenient, that can be converted into maintainable. So if you can get something like that, it's convenient for you, and then you can convert that into maintainable. What is that? How can you build that? So that's bother us. We wrote tools that help people write tests, and we want people to write tests, and they go, oh, we can't. Why? Because the framework doesn't let me. It's all too convenient, and now because it's so convenient, we can't write tests. Oh.
It's quite opposite, because I wrote a tool that helps you to write tests no matter how bad your application is. Yeah, and then when we switch to the inside layer, it actually cares about the quality. And for Marcel, it's quite opposite, because his tool exposes the problems of the inner quality. So but it doesn't says that Behat doesn't care about the quality. It does. Both of those, they combine the quality of the product, as Jakub said during his talk.
So that's the fascinating thing. So if you look at a convenient the framework that is convenient, or a framework is convenient when it makes choices for you. Right? You don't have to worry about how you're going to redirect. You just say, call this redirect, and it's going to redirect for you somehow. This get doctrine is going to get doctrine from somewhere, some place that is there. And you have all of these dependents on collaborators just available for you very conveniently. Yeah. But you want to stop those collaborators. It's not that clear, because it's a relationship, it's an inheritance. It's not really a clear composition. You're not composing objects at runtime sometimes. Or you have to find out where the objects are. In some frameworks, it's harder. The thing here with Symfony, you know where they are. You know what is being used and how they're being composed. And you can kind of decompose the framework and create that replacement at runtime. And it's more decoupled.
So framework is convenient when it makes choices for you. This is when framework is convenient.
So you have a mentality of inheritance as opposed to composition. And the maintainable is the other way around. When you call the code is maintainable when the framework lets you make the choices, right? So if you can have something that is convenient but also can transform into maintainable, which we think is the case here, then you are in a route to have something more.
So this is the trade-off we were talking about previously. It's almost like opposites, and you want to have both at different stages of the project, and you want to be able to choose between those two. It's maintainable code. It's opposite of easy and quickly written code, right? It's almost as easy as like that.
All right. So if you're familiar with PHP Depend, anyone? Yes? Used PHP Depend? Some of you? There's a graph on PHP Depend that shows the relationship between instability and abstractedness, which is basically the relationship of afferent coupling, which is, does my module depends on modules outside of my modules? And what are the natures of these modules? Are they concrete implementations? Are they full of abstractions? So if you have something that is concrete and depends on something that is concrete, it's going to appear on this bottom left of your graph. If you decide the bottom left of the graph there. This is what the theoretical people call the pain zone. It's when you have couple things. You can't move things, or you can't replace things anymore. And then when you have abstract things that never get used by other modules, it's just like these abstractions that nobody uses. This is called the useless zone.
And you almost get into, on all the projects, you get into the situation where you have like, I don't know, tens of abstract classes that you have no idea who uses them. And it's like, and it's not, you can use tools to find who extends this class. But there's fit in it, it sits in you. You don't know where this class is used. You don't know, you can't put this tree of classes and inheritance in your head. You just know it's there, and you're afraid to remove it constantly. And it's like you're forced to use this tool to see dependencies tree every time you want to change system.
The convenient code sits here, all the base controllers and base stuff that you extend and you have to extend in domains of certain frameworks. So the convenient code is usually not very testable. So if you have to work in a framework that have all that convenience for you and gets all the things for you, and you have to replace it in runtime and you can't, and the only way around it is to do something bigger than unit tests.
Yeah, because there is usually two ways to bring convenience in the code base, and those two things are bringing something from the outside of the system and hiding it from you, so providing you like interface on top of that. So this is what convenience layer does. This is what convention layer does. It brings everything out of the framework and hides it from you. So you're kind of using it, but you don't know what you're using, and there is everything underneath. But you're not controlling it because it's a convenience layer.
Sometimes the developers think, well, I'm going to add this extra layer of abstraction here. Am I adding complexity? You should always be thinking, I'm going to skip this layer of abstraction here. Am I adding convenience? You have to think about that too. Because when you're adding too much convenience, you're going to be screwed down the line when you're going to test that thing. So Symfony can be convenient. This is an example from the documentation. It can allow you to use a framework without having to worry about how you're going to unit test things and just buckle up everything in a controller and keep going and everything is rolling there. And you don't know where things are coming from. They're just there available for you.
But oh my God, it's convenient.
And Symfony can do that for you. Can play both ways.
And there's the fun part that underneath that, deep inside, it is still really well-designed system with decoupled components wired together. It's just a convenience layer on top of them. And there is a lot of talks in the communities in different languages nowadays, especially in Ruby community and in Java community, talking about the same things. But it's so interesting to kind of to listen those talks because people are kind of saying about trade-offs, but they have different kind of trade-offs. They don't have choice between design or no design or convenience and maintenance. What they have a choice of what Rails does and what I can do to do as much as possible of design without Rails getting in the way. Because there is a framework which is highly coupled and you can't do anything about this. And it's like every time I'm seeing those talks and people are struggling, they're trying to find a way how to get away of this, get around. And every time they're kind of getting with some solution, I'm thinking, we already have this in Symfony. We're just like hiding it under convenience layer. It's already there. We're just not using this. And those guys have frameworks, brilliant frameworks, and they struggle to bring it there because nobody thought about this maintenance when the framework was written.
Right. So if you're writing something small and you're not worrying about quality, if you're not worrying if you're building a website for your aunt or anything like that, and it's something small and it's not going to grow, and no problem doing anything like that. Problem comes when you have tests needs. You need to test your stuff. And the convenient controller is really a place to ask for more integration tests. More integration tests, please. It's like dying for integration tests.
Convenient controllers, the unit tests, they just don't fit there. It's really, really hard to unit test convenient controllers because unit tests, by definition, they're atomic. right? You define atom operations. And convenient controller, it does everything. Everything from the get-go, and it hides it from you. And you need to uncover it with unit tests. That's why you need integration tests.
So if you see yourself having this conversation with your developer peers and say, hey guys, it's not possible to do any unit tests here. Unit test is just one unit test for that thing. That's all you can do. Let's do an integration test just to make sure that the other things works as well. And if the number of integration tests is growing, you should stop and thinking what's going on. This is a smell. If you have much more integration tests, then actually it's not a smell. It stinks. Integration tests stinks of coupling. Okay? If you have to rely on integration tests all the time, most of the time, rather than being able to separate things and test at unit level, there's a high degree of coupling, a high degree of convenience there.
Integration tests, they're kind of testing analogy of convenience controllers. They're bringing everything, but they don't hide it, right? They expose it to you. Integration tests, they're like tooth fairies. The more coins you get, the less tooth you're left with.
Right? So what you're looking after is you're looking after inner quality and looking after outer quality. Integration test sits in the middle. It gives a little bit of both. So if you can shift the focus for these things, okay, let's think about how we take care of outer quality, how to take care. If you have the things decoupled from the convenience layer into proper defined domain layer, then you will be able to unit test and have a right amount of unit tests that you can guarantee inner quality. Otherwise, you won't be able to have that. You're going to have to rely on integration tests.
And this is exactly the conversation that we are having like for recent years. This is exactly the talk that we delivered last year. This is where full stack BDD came from, right? This is all about separation, those concerns and responsibilities, separating outer quality from inner quality and concentrating, focusing on things that matter for each one of those, creating higher quality overall on the projects. And you need to have both acceptance tests to prove your outer quality, and you need to have unit tests to prove your inner quality. The problem comes when you're trying to bind those together, and this is where those trade-offs come into play, because you need to choose what you want to do. Do you want to do more integration tests, or do you want to do testing overall? Or do you actually care about design of your project, or it's like 1 month's project and it will die in 2 months?
Right. It takes us to choices. Okay, let's talk about choices. So this question was asked upstairs. We just went to hear Jakub, and I want to hear from you guys. Who do you think is right? Should we always do TDD? Because Jakub convinced us upstairs, and we all agree with him that we do TDD for everything for the rest of our lives. We are under oath now. Brainwashed us. But what do you think? Should we do TDD for everything? You agree with the startup guy who says, not really? Or do you agree with the craftsman who says, yes, please?
Yeah, there is almost like the market where there is two voices speaking loudly on the same level, and one of them are saying, startups are saying, you know, like, let's crack something really, really quick because we need the product, and another guys are saying, no, you need to go properly, you need to have like high quality, you need to have design, because every project on the market, in the long term, it will grow.
Yeah, so who is startup guy here? Who believe that we should do the startup way? Yeah?
Raise your hands.
Don't be shy.
Don't be shy. I knew it.
And craftsman? Any craftsmen here? Oh. Okay, cool. So let's talk about choices. We are test-driven design people. We do test-driven design. And there's something about the design of the test-driven here. When we're talking about design, the design really is about making choices. It's expressing those choices in a way that tell how you're going to solve the problem. Okay, a problem is presented to you, and say, let's think about it, and let's present a choice. Let's present how you're going to solve this.
And let me clarify it a bit. Choices, what kind of choices is this? The question that Marcelo asked before, are you more related to startups or are you craftsmen? Both answers are right. Okay? Both answers are good. It's not good or bad. It's not about what you choose. It's not about big or small projects. It's not about going quality or not going quality, going test or not going test. It's not about what you choose. It's how you choose it. it's not about being bad or good. It's about making constant choices and being aware of them.
In other words, there's no right answer, because and that's what people want from when they learn design. Okay, how do I design this thing? I'm not going to tell you. You're going to have to learn it, because design is a professional activity. You have to learn that design is all about trade-offs. You have to learn that if you do this way, you get these benefits and you get these drawbacks. And if you do this way, you get these benefits and you get these drawbacks. And this is really hard for people coming from a perspective. I want answer.
Yeah.
That's how I learned PHP. I just copy-paste from the web. Please tell me.
And this is there is a split between us too, because in the company what happens, Marcelo is all about choices. When newcomer comes to Marcelo and asks something, Marcelo provides him like with different choices and leaves him. And the guy is like, what? But then guy comes to me. I tell him, okay, you need to go this way, right? And a couple of months on the road, oh, Marcelo also provided this choice, and I think it's better, right? So you learn to choose when you think about your code. You learn to choose, and choice is a big part of design. It is a design. You learn to choose when you have those options and you try them out. There is no way to choose if the only option you always try is one single road. You can't choose if you don't have options. That's as simple as that. And you don't have choice if all the thing you're talking about is being bad or good, because everything is bad and everything is good.
Okay, so how do you choose? So if you've got to choose whether to go TDD or you're not going to do TDD, then one thing you need to know that TDD is not about test at all. It's the wrong name. At least you should call it refactoring-driven design or something like that. But a lot of TDD is about communication, right? So you need to keep a level of communication with your team. You're communicating to your team like Jakub was referring that some guy on the project ran the PHP spec and knew exactly how the classes were working in the project just by running the tests and reading what is it that the classes do. So it's about communicating. You're communicating how the classes work. You're communicating at the acceptance test level. You're communicating how the feature works and validating with the customers that those features are working. So it's really much about communication. And communication with various stakeholders. Okay? TDD is about your relationship with the stakeholders. And bear in mind that there's one key stakeholder here, not just the customer who is going to see the feedback from the tests, but also the team. Okay? You're going to have to keep this team for this code base, for the lifetime of this code base. And if you're not test-driving that code, if you're not applying inequality to that code, then eventually that will deteriorate. Your relationships will deteriorate.
And
okay?
it's even more than that. We are used to think about the team in terms of constants, but it's not as simple as that, because teams are changing. People are get hired. People are leaving companies to better companies or to worse companies. Teams are changing. And it's not about developers that are working on this project right now. It's about developers that will work on this project tomorrow or that will come back to this project in a year.
Yeah, so when you're deciding whether you're going to do TDD, don't think in terms of small code base, big code base. Think in terms of short-term relationships, long-term relationships. So if you are a startup guy and it's your code and it's your product and there's nobody, it's just you writing your new version of the new super duper application that's going to conquer the world, you can forget about TDD and go nuts with your code. But if you have relationships to maintain, right, then you're going to have to think differently, because the other guys are going to have to live with the mess that you're creating. And there's the customer as well, and there's the users.
And there is one bit which people are missing, and it's BDD and where it came from. And BDD is actually a solution to help your relationships in the team. And the funnest part about BDD is you don't need two persons to have relationships, because you could even have a relationship with yourself, right? In 1 month, in 2 years, yourself on the different schedule of the project, it's a different person. It's a different experience, and you need to talk with them.
Having said that, how do you, going back to our controller class, and we need to TDD this thing. We need to crack down the dependencies. Can you spot the dependencies in these 6 lines of code or 10 lines of code? How many dependencies do we have here? Anyone? Doctrine? Yeah? What else? right? Yeah? There's redirects. Woo, woo. All right, there's a bunch of dependencies there, right? If you want to isolate those things and test in separation. So we came across this thing, again, from the past, not very remote past. This is 2008, from one of the signatories of the Agile Manifesto, Alistair Cockburn, called the hexagon architecture, all right? Which, by the way, has nothing to do with a hexagon. Hexagon is not a hexagon because the number 6 is important. Forget about this hexagon name. It calls hexagon architecture. It has nothing to do with the hexagon. But rather to allow the people doing the drawing to have room to insert ports and adapters. So you have an idea that you have many places that can come in into your application. You can isolate these dependencies through ports.
So it's the same like it could be circular architecture.
Right, so you have your application in the middle. And your application is really your application, nothing to do with Symfony. It's what you're building, is your domain, is your application logic, completely there in a core and in the center. And around it, you want to talk to Symfony to deliver your framework to the web. You have a port. That's an interface. There's an interface that's going to talk to that adapter, which is the web application. Okay, so you have ports and you have adapters. The ports are the interfaces that will link your application to the world, and the adapters are the bridges between the application and the technical level, which may be many.
Yeah, and there is a point on, I heard this argument a lot when people are preaching for interfaces, ports, protocols between objects. It's like, the argument is, if you will want to switch the framework, but nobody switches the framework, people have big problems relating to this argument. And the thing is, you're not switching frameworks, but framework is changing. It is constantly changing, evolving. Symfony goes through a version really, really quick. And every time you have some changes here and there, small BC breaks, and if entire application depends so much on your framework, it means you can't move forward as framework moves. And also you can't anymore use new convenience layer, new tools in convenience layer because you can't migrate. That's the thing. It's not only about changing frameworks, it's about evolving framework and being able to grow it faster.
Yeah.
Or even growing framework, choosing different frameworks for different application, even like your domain will stay the same. Even if it's API or mobile application, it will stay the same. You just need to provide different interfaces to it.
Right, so there you go. You have the application in the middle, and then you have here a web GUI application written in Symfony, and you have your test adapter also hitting that port, and so you're running a test against your application without even having to worry about the delivery mechanism. That's wonderful. And at the other end, you have databases, for example, and you can use the real database access service here. And when you're testing, you can use any more in-memory database. You can replace the dependencies in runtime very easily. So that's the theory, and that's how it looks like. There's all this hexagon, but it's in numerous sides. If you have 8 services, you have 8 sides. It's not hexagon because it's 6 sides, right? So, so just before we show you some code, this down the bottom, Alistair Cockburn talks about the dependency inversion from the solid principles. And it's really important to, it's just a couple of slides for you to understand how this works. This is what dependency inversion is all about. Higher level modules should not depend upon the details, which means that your use cases, the entry point, or if you want to call it services, the entry point of your application should not break if something down there, your util classes, your libraries change the way they operate, right? High-level class should not depend upon the details implementation. So instead, it should depend on abstractions. And then the implementations you have implementations of the details, different implementations that will implement those interfaces in different ways. So you don't break, your use case is not going to break if you choose a different implementation detail later down the line. Does that make sense? Okay, so it looks like this is the naive implementation. This is how we do it these days. From the controller, you instantiate your service or get from the container, right? Because it's a cool thing, pass the container to your entities. And then from there, you use a a utility class, right? This is the naive implementation. You straight down the line, everything concrete implementations. So an alternative way, and this is what makes possible for you to do hexagon architecture with Symfony, is that you can have use case classes, which is going to have access to the service, which is an interface, and you can implement that services in different ways. So you can one day be talking to a repository that is a database repository, and tomorrow something is a service that brings the data from somewhere else. And again, as you go lower level, you do the same principle, the dependency inversion principle. The high-level class does not depend on this class anymore. It depends on an abstraction. Does that make sense? If this change, this guy doesn't break.
And
right?
that's the whole point of interfaces and protocols. The idea of interfaces is to hide states and expose messaging or communication between objects. And what this principle actually says is depend on communications of the objects rather than what those objects are.
Who needs to see some code?
Yeah. So we thought that there is a plenty of talks like this which talk about the theoretical part. But it's really hard to apply into life because the principles are so high level, you need to know different details and how you implement and how they apply it. And we had this quote where we think that it's really, really applicable to Symfony, but we haven't seen examples of how it could be applied in some particular way. So we prepared this small example application that we want to show you. It's not live coding, so not like last year. We just show you the code that is already written. And basically, we tried to follow hexagonal architecture. But thing to keep in mind here in this application, the subject of application is trade-offs and choices. Every time there is a choice, every single decision, even ports and adapters, you need to think about this. And if there is a good reason, you can avoid creating new interface, and you can just create directly class. The thing is not hexagonal architecture on its own. It doesn't solve the problem. Your choices are. So this is this example application. So basically what it does,
Maybe you should show the feature file.
Yeah. So it is a ceremony tracker application which tracks agile sprint ceremonies inside sprints. So basic idea is there are managers, project managers, and managers can create project. So in order to be able to track my project ceremonies as a project manager, I need to be able to create project. So scenario, successfully creating a project with a name. Given I'm a project manager, when I create Nokia project, then the Nokia project should be saved, and I should be notified the project creation is successful. So this is like high level, and this is something that we were preaching for a long time. There is no GUI, there is no web interface there, and this is the detail that helps us to drive those features before even application started, before we even have SRC folder. But in this particular case, we want to show you this SRC folder, so here it is. So we have this high-level namespace, which is a company name, which is a convention, which is Sensio Labs in our case. And we have 3 sub-namespaces there. It's ceremonies, ceremony tracker, and ceremony tracker bundle. So what those namespaces do, ceremonies is your domain, is your domain object. It's your code representation of what your domain area looks like. It is all about ceremonies, project, specification, sprints. And those are really easy, plain old PHP objects. And there is one interesting case here. It's like every project has a name and is assigned to a specific project manager. But this is kind of creation dependency, and you can't have a project which doesn't have a name or project manager. So you don't have setters. You're passing those as a constructor. You can't change them. They're immutable objects. And most domain objects are actually immutable if you think about them. And so in addition to having those domain objects, you will also at some point will need to save them, create them, or persist them, or retrieve them from somewhere. But we don't care about persistence layer. What we care about is saving project somewhere and getting projects for specific project manager. This is all we care about. and we don't care about how it will be implemented. Will it be Doctrine? Will it be ODM, ORM, Propel? We don't care at this point. We care about protocol of communication. And then, in addition to ceremonies, which is our domain, we have ceremony tracker, which is our application. This is our application. This is what it does. It's a set. Every application is a set of use cases. It's how you use it. It's what you do. But this is, again, decoupled from Symfony. It does nothing. It does know nothing about Symfony. It's higher level about your domain, but does not know anything about Symfony. From the specification repository, if there is no specification, then it dispatches failure event and returns. So it stops. It does nothing. If there is a specification, then it applies this specification to a sprint, which populates sprint with specific ceremonies, and saves this sprint to the project repository, and then dispatches success event.
Now, what is interesting here is that because it uses event dispatcher for Symfony, it doesn't mean that it's linked to Symfony. A Zen framework application could also use that dispatch mechanism to notify their controllers that this is working. So it's completely decoupled from the, can you just show the controller?
Yeah. So this is ceremony tracker. This is your application set of use cases, how domain would be used in different situations. And then, of course, you have ceremony tracker bundle, which is simply wiring up those use cases into Symfony. And this is, for example, controller for creating project. There is no extension. It doesn't extend anything. It doesn't depend on anything. And if you think that every time you're doing your extending controller, you're trying to call some parent methods, it does a lot of things, it's not really true. There is actually only 5 dependencies. And every dependency makes sense. If we have create project controller, we need a use case, which is decoupled from Symfony case of creating this project and putting it into the repository. We have a token interface because we need a project manager, right? We need to get user, which is a project manager, out of the security component. We have a form interface because we need a form to create project. And we have a flashback because we want to put this in flash message into this after saving or on the failure. And then we have a router because we need to generate redirect response. At some point, we need to know about the URL where we want to forward people to.
So these are all controller stuff.
Yeah.
You know, this is not stuff that has to do with our application. Our application is completely isolated. We have router in the controller, flash in the controller. All the stuff that's controller stuff is in the controller. All the stuff that's application stuff is in our application.
So what happens here? We ask project form to handle request which is passed as an argument. And we check if this project form is valid. If it's not, we generate failure event, and we return redirect response. And if the project form is valid, then we instantiate project form instance from the form data. And this is one of those trade-offs. You can use data value objects, or DTOs, to help your forms to help your forms have some objects to operate on. But in most cases, like in this particular case, project just has a name. Oh, geez. So project just has a name, so you need just one field, and array is more than enough for this. And let's look just for an entities. So there is this project repository, and this is about complexity. So this is how you wire up all your domain layer, all your repositories into the Symfony. Missed it. So you see, everything related to Symfony suddenly gets there. Even controller doesn't know anything about Doctrine. And especially your use cases and your domain objects, they don't know anything about Symfony. Right? So we're out of time?
Yeah. But I would like to thank you for listening to us. Everside is going to pull it up. This is in a GitHub.
We missed future.
The future, yeah. We can talk about the future on a coffee place.
Yeah.
And this is a joined in link, 9331. We really appreciate your feedback. And thank you very much for listening.
Yeah, and feel free to talk.